The Argus Mytic has numerous models, and I talked to Brother Fitzgerald there about some of that prior to this. So the one y'all are using is the Mytic S. It has a little bit wider screen on it. It's the top of the line model. The field of view on the camera is 37 by 50. It uses something known as tri-mode sensitivity instead of high and low sensitivity. We'll talk about that. It has one of the higher pixel counts or detector on the market. It's a 384 by 288, which is over 100,000 pixels, which sounds great at first. We've got to do some math and look at some differences here. The refresh rate on it is extremely fast at 60 hertz. The temperature range is -40 to 2000 degrees Fahrenheit. And from where y'all are working, when you get some nasty weather, you need to remember this about this camera. Next to Bullard, this is the toughest housing on the market. It's almost indestructible. I always say almost because there's always one firefighter. Ooh, challenge accepted. I'll break it. The other thing that it has that a lot of people don't know about is the germanium lens. Right here is where I told y'all to wipe the lens. If this ever gets broken, for about $200 or $300, you can change it yourself. You change the 8 screws and put it back. Only 2 cameras on the market offer that. If you break it on any other camera, it's going to cost you over $1,000 to fix it. It has up to 9 firefighting application modes. It's extremely well insulated. It can take a lot of heat until the inside of that core gets over 500 degrees for 5 minutes. If you ever see a red triangle in the top center of that screen with a little thermometer show up, that means the inside of that thing has been over 500 degrees for 5 minutes. It may turn off, may quit working. You're in a bad place if you ever see that. I'm just warning you. That means you probably melted the nozzle at that point. It's extremely sensitive. It can pick up the differences between a victim and about a 99-degree pile of clothes. That's in what they call millikelvin. When you talk about thermal sensitivity ratings, millikelvin means 1,000th of a degree. NFPA says no greater than 80 millikelvin. Yours is 50. The best ones on the market are 30. You can't get any lower than that without going into what's known as a mid-wave camera. You want to see some cool stuff? Google mid-wave cameras on helicopters. They're looking at stuff 8, 10, 12 miles away and saying, man, he's wearing Ray-Ban sunglasses. That's pretty cool. They're pretty detailed. Your camera is NFPA 1801 certified, which means it's also intrinsically safe. Your camera is one of 3 on the market that uses something called image enhancement. Out of the 3, I'd say it's probably the bottom of the image quality, but it does enhance the image. As you can see in the picture here, that the edges of the shipping container are showing very clear on the bottom. The problem I have with their image enhancements, if you look over their heads where the convection currents is, you don't pick up any detail behind that. True image enhancement doesn't block out the detail behind it. FLIR, Bullard, and Argus all offer it. The Ignis engine is the one that has the most image enhancement. This is something you can print out, put over the toilet, call it potty training minutes, whatever you want, laminate it, put on the fire truck. Helps you remember what these colors mean. If you see, hear me when I say this, gray, white moving stuff over your head, do not ignore it. If it's all the way down to the floor, do not advance. Stop, back up, try to go in a different way. If you are crawling and your mask and your tick constantly fog up, constantly, the fire is either beneath you or you're crawling in an exhaust. And you're not going to see squat. Okay. So gray and white convection currents are hot. Doesn't matter about color. They're hot. The reason you don't see color is they don't have a surface behind them heating up. As whatever they heat up behind them heats up enough at 300 degrees approximately, they start to turn yellow. But notice it doesn't come out of yellow till 900 degrees. Then from 930 degrees to 1100 is orange. If you ever see red with this camera, not good. 1100 to 2000 degrees Fahrenheit. See the little green triangle on the bottom left-hand corner? The older Arguses have them down here. That's low sensitivity. This is fire mode right there. The newer ones will have the green triangle showing up in the upper left-hand corner. Your recordings don't show that triangle. You can go back and change the settings on it where they show up. These are the selectable application modes of the camera. I am not a big buttons guy. I'm just telling you. I like 1 or 2 features. That's it. Because under stress, it's not an Xbox game. If you're doing hazmat and USAR and all kind of other stuff, okay, I can see that, but you better be trained on all of these. 9 different application modes that you have to toggle through under stress. And do you know what each color and what temperature that correlates to? Because if you don't use it. Stick with fire mode or size up mode, which we'll talk about. The overhaul mode looks really neat, but it only colorizes the hottest 2% to 5% in the image. So that means this room that's on fire can really look like it's on fire. Then I can go look at a room that's over 100 degrees and it'll look yellow and red in certain areas because it's colorizing the hottest 2% or 5%. The neatest feature the camera has, in my opinion, is hot heat seeker or cold seeker. Cold seeker is really beneficial for locating a downed firefighter for RIT, hoarding environments. It'll find the pathways like Ryan Pennington teaches us. You can find holes in the floor. You can find a downed victim, lots of different things. CO2 leaks, you can see the CO2 where it's cooling that environment, picking that up, all of those. And this is the explanation for search or overhaul mode. This is why I said you need to be careful with this, because look what it says. Red colorization is added to the hottest 2% of the scene, and yellow is added to the next hottest 5%. You can tell this camera is made overseas because look how they spell color. It's got a U in it. So that's how my friends overseas spell colorization. It's like color. Your camera has tri-mode sensitivity. Instead of high and low sensitivity, it has high, low, and extended low. The thing that Argus did right is you really never know that it has tri-mode sensitivity. The color bar stays the same, which is awesome. And you'll see the green triangle show up and it may flash when it switches to low or extended low. The older one went, you didn't see anything. You saw a green triangle and you saw a red triangle, which meant you were in a bad place. It's doing that to adjust and see the heat better. Okay. High sensitivity mode works between -40 and 302 degrees Fahrenheit. And you think about this, if you are functioning in an environment and the triangle staying engaged, meaning low sensitivity the majority of the time, you are in a non-tenable space for a human victim. Think about that. If it's staying that way the majority of the time and we're not cooling it off, we're not making it better. So your goal should be to bring the camera back to high sensitivity the majority of the time, because you're giving them a chance, stopping property damage, stopping thermal insult to firefighters. Your camera will automatically switch when a certain amount of higher temperatures have been observed or picked up, and that green triangle will be displayed in the top left corner. That's in the newer models. According to Argus, your image will still be clear with lots of detail. That's a manufacturer statement. The majority of cameras on the market, when they switch to low sensitivity, lose detail. They do. It's factual. There's only one that I know of that gets better in low sensitivity, but it's not that good in high sensitivity. It's the reverse. So they all have a trade-off. There is no perfect camera on the market today. Sorry, there was. I just talked to you about that one. And I don't sell cameras. I try to train people on all of them. That's why we read instruction manuals all the time. When you talk about extended low sensitivity, your camera is operating between 1100 and 2000 degrees. Should we ever theoretically be in that? No. I mean, if you're looking at the building as it's burning down, you're looking inside of a flashover container when they've let it go, maybe, but you shouldn't be in it, period.